Okay, looking at problems for section 10.4, prediction intervals and variation. Okay, so on this section, we start discussing many key features that are going into the problems itself and kind of trying to describe what is truly going on. So if we look at number 6, okay, so on number 6 here we talk about that R equals 0.963. And then they tell us X was the chest size of a bear and Y was the weight of a bear. Okay, so we're trying to compare the chest size to the weight. So they give us an R value here. It tells us that use the value of the linear correlation coefficient R to find the coefficient of determination and the percentage of the total variation that can be explained by a linear relationship. So remember, that was R squared. So R squared had two different formulas. We could have either took our explained variation and divide it by the total variation. Okay? Remember, the explained variation was our summation of x hat minus x bars squared, and then we could have divided that by the summation of our total variation. The total variation was our summation of y minus y bars then squared. So basically it's our difference from our prediction to our mean, and then this was the actual to the means then within here. So this was basically our R squared values. But we were given R in this case, so we can very easily just go like this and go 0.963 squared. 0.963 squared yields us with 0.927. Okay, so if we have 0.927, what this is now telling us is it's telling us that 92.7% of the variation in weight is explained by a linear correlation between chest size and weight, and 7.3%, once again 100% has to be accounted for, so this is explained. 7.3% of the variation in weight is explained by other factors. Okay, so basically we're saying that 92.7% of the weight of a bear is going to be explained by his chest size. But there's 7.3% of that weight that could be some sort of other factors in there. For instance, a bear that lives at the park and likes to steal picnic baskets. He'll be probably larger in size because he's eating a little less unhealthy and a little more aptitude to having those good old picnics that he's working with. Okay, so this is kind of the basics in this section given this information. Do realize this section goes by far in more detail than what is necessary for this class. But I'm going to kind of walk you through an overall big problem of how you would find everything and what you would do. So if we were to look at number 18, okay, so I'm just going to put number 18 here. I have this written on a separate sheet of paper because of the extent that really goes into it. So number 18, we start talking about the list below are the amounts of court income and salaries paid by town justices. All amounts in the thousands of dollars. We want a prediction interval using 99% confidence level with the court income of $800,000. So what we're doing is we're trying to treat that X equals 800. Okay, and once again, the table's in thousands, so this is our income. We're trying to figure out what that justice salary would be, once again, as a prediction interval. Okay, so we're going to do a prediction interval. Okay, and then once again, we want 99% confidence on this, or 99% prediction interval that we want to be within here. So some of the things that we got to start working with is the simple fact that we need to have, let's see if I can get this on here so you can see, total variation. Okay, so total variation equals explained variation plus unexplained variation, which we covered in that previous problem with some of those. We have our explained, our unexplained, and then our total variation going in here. So what we would do is we would have to go through and we would have to take each x value itself, and we would have to figure out what are we doing. So if this was a linear regression, we would have our linear equation, y bar equals 27.7 plus 0.0383x. If we took the mean of all our y values, we would have 44.2. So what we would do here is we would take this and we would state, okay, here is our overall y bar for our predicted 800. So we said that we have 800 in here, our y hat. This would be our 57 in here. So what we would have to do is we have to take our y value that we had for each of those and we would subtract off our y bar. So that's where this column right here comes in. We would then have to find what our predicted value would be for each income. So remember, our incomes varied. We had a 65, a 404, 1567. Now remember, these are all in thousands, so that 65 was really 65,000. What it is, I plug those into my predicted equation right here, and I found all these. Then I take my y minus this. Once we have this, we're going to look at the summation of this and then this right here. So we have our summation of y minus y bars, which was our total variation, and then our summation of y minus y hat squared right here, which was our unexplained variation. Now the reason why I did this is because I got to find my explained variation. So if I just simply plug into my formula, my explained variation is 3,209.83. Now to construct that confidence, or with 99% confidence, to construct a prediction interval. Our prediction interval has so much stuff going in. So remember, it's a very complicated equation that I said we would use in a calculator if we have to use it, where a calculator doesn't have the capabilities. So this is what we would go through by hand in doing it, so I do realize you're not getting a problem to this extent, but this is what would have to go into it. We would have our y hat minus e and then our y hat plus e. So we have to figure out what our error would be. Now remember, our error was this very ugly and complicated formula within here. So what I did was I took my degrees of freedom to be 7. Once again, we had 9 pieces of information, but remember on this it was n minus 2 within here. Two-tail, so I got my t value within here, so I plug that into that equation. Then my s of e is the square root of unexplained divided by my degrees of freedom, so that got plugged in here. I'm predicting for 800. My mean input was this, the summation of x. So this formula had all this stuff in here. I figured out as I plugged it in, and I found that my error was 47.11. So what we do now is, remember back up here, I said I plugged 800 into my formula, my linear regression line. So I put 800 in here for x, and I got 57.54. So now what I'm going to do is I'm going to take my 57.54 minus 47.11, 57.54 plus 47.11, and I get this interval right here. So what this is stating is it's stating that our prediction interval for a courthouse that has an income of $800,000 is going to have a justice salary from $10,400 to $105,000. Okay, now do realize this is a very huge range of salaries in here. But once again, because we wanted 99% confidence on this, it's going in. Now, because of this range is so large, we could be thinking, well, maybe it's not truly linear. It could be a different style model in here. It also could be the fact that because we're trying to be so confident, we're just raising up. Maybe we want to lower our confidence on here to have a little better indicator on this. But this is the true extent that goes into these problems. I do realize this was a full page of paper that I wrote this on, and not necessarily the smallest. But that's what that problem's going into. You're going to be asked to do more problems relating to this r squared value and what's the meaning of this r squared value for this section.